first by reminding you the format of a geometric series. So remember that this is, when I write the series as a sum here, it should look like AR to the n minus 1. And when do we know when the series converges? If there's a condition on R, right? The absolute value of R is less than 1. And it's going to diverge otherwise, right? Diverges if the absolute value of R is greater than or equal to 1. And then we also have a formula for the sum when it converges. Do you remember the formula?
A over 1 minus R.
Yep, the formula was A over 1 minus R. All right, so let's do a new problem. Is the series the sum n equals 1 to infinity, 2 to the 2n, 3 to the 1 minus n, convergent or divergent? So if you look at the way this series is written, it doesn't look like a geometric. To look like a geometric, I need to have a constant and I need to have a power of n minus 1. So right now, what I'm given in this problem does not look like a geometric series. So our goal is, if we want to see it as a geometric series, we need to rewrite it. Okay, so let's see how are we going to rewrite this. So let's sum from n equals 1 to infinity, 2 to the 2n, 3 to the 1 minus n. So it's really made up of two pieces, right? It's made up of this 2 to a power and this 3 to a power. So I'm going to focus on the first piece first, the 2 to the 2n. I'd like to rewrite that so that the power is just an n. Okay, n equals 1 to infinity. So I want to rewrite the first term so that the power is just n. So what should go inside the parentheses? Two to what power? 2 to some power. 2, I heard someone say 2 squared, right? 2 squared? Because when you have a power to a power, they multiply. So that'll give me 2, the power 2n. Okay? So, but 2 squared is really just 4. 4 to the n. So I already like this power of better. So what I'm going to do for the 3 is notice that the power for 3, the n is negative, right? Has a negative n. I'd like for the coefficient of n to be positive, so I'm going to factor a negative 1 out of the power. Okay? So factor a negative 1 out of the power, so it'll be in negative n minus 1. What happens with negative exponents, like x to the negative second? How can you rewrite that? Rewrite it as a fraction, move it to the denominator, right? Same thing here. I have a negative exponent, so I'm going to move it to the denominator to get a positive exponent. So n equals 1 to infinity, I have 4 to the n over 3 to the n minus 1. things have gotten a lot better for me. Remember, my goal is to have something in the form a times r to the n minus 1. My denominator has the right power. It's n minus 1. But my numerator does not. It's too large. It's n. I want it to be n minus 1. So I'm going to take one away. So you rewrite it as 4 times 4 to the n minus 1. Okay. And now the 4 and the 3 have the same power, so I can combine them into one term. And it's going to look like 4 times 4 thirds to the n minus 1.
What did you do to get 4 times 4?
What I did is I took one of the 4's out. You know how when you write, let's do 2 cubed, it's 2 times 2 squared? The same thing here. I took away one of the 4's, so the power went down by 1. Okay? Yeah. Other questions? So do we now see that this is a geometric series? What's my r? 4 over 3. Once you know the value of r, you can immediately determine if this series converges or diverges. What do you think? It diverges because this is a number bigger than 1. This series diverges. Okay? So with a lot of these geometric series, all you have to do is manipulate the formula that's given to you so that you can identify what R is and what A is. Okay? Any questions on that example? Okay, let's do one more geometric series here. Find the sum of the series n equals 0 to infinity. Make this up a little bit. X to the n, where the absolute value of x is less than 1. So you're thinking about x as being some kind of number, and you're requiring that the absolute value of x be less than 1. Okay, so let's write out some of the terms of this series here. Just so we can see what terms we have. So what do I get when I plug in n equals 0? X to the 0, 1, and then x squared, x cubed, and so forth. Do we all agree that this is a geometric series? What's my R? What am I multiplying by to get to the next term? X, right? X every time. So this is a geometric series. My first term, A, is 1. My R is X. And they tell me that, so if I look at the absolute value of R, it's the absolute value of X, but they told me that this is less than 1. So does the series converge or diverge? Converges. Great. Which is why they asked me to find the sum. So to find the sum, we just now need to use the formula. We've identified A, we've identified R. So we can now write the sum of this series is A, which is 1, over 1 minus R. Any questions? Yep.
How did you get that extra decimal?
They told me that in the problem. So if we look back up,
Okay.
they tell me this condition where the absolute value of x is less than 1. If I didn't know that, then I wouldn't know that the series converged, and then I couldn't find the sum. Yep. Other questions?
How exactly did you get to whatever?
I'm using the formula for our sum, which is, so the formula is a over 1 minus r. And I'm just plugging in my a and my r.
Okay.
Okay.